Hey, hello, this is John Maxwell in AP Computer Science. This week's lesson is about Booleans, how they're used to make decisions in programs, in everyday life, really, because programs interface with us in many different ways. You know, I recall the Rocket Mortgage ad, which has a bunch of people typing in on their phone, and then the message is you're approved, right? Obviously, they gave it information, and according to the decision rules, you're either approved or not. So these things have great impact in the computing world as well as our life. So we're going to start off here with a simple if else structure. And here we have A equal 10 and B equal 5. And we ask, is A less than or equal to B? And A is not less than or equal to B. So it goes down to line 10 and executes whatever is in between the braces of the else clause. So it says A is not less than or equal to B because 10 is not less than 5. One thing you ought to notice, and it's a beginning mistake, is that the else clause has no condition. It's executed when the if clause is not examined as true. So let's run this and we'll show you that it will be 10 is not less than 5. So take a good look at this. This is the basis for computer decision making at its most elemental and rookie form. If something's not true, then the else clause gets executed. Well, moving right along, we have an else if example, which is a modification of what you've seen in the book or what you will see in the book. And in this case, we have an average, 61.5. Let's make it more like what most of you would have, 92.5, or a grade in the 90s, which will assign in this selection structure. They call these selection statements because the if clauses help the computer select what statements to execute. And so if the average is greater than or equal to 90, and that's assuredly what 92.5 is, then the letter grade is assigned an A. Else greater than 80, else if greater than 70, else if greater than 60, assigns to letter grade, respectively, B, C, and D. And then else is the catch clause, which assigns a letter grade of F. Again, the else clause has no Boolean condition that needs to be evaluated as true. It's just what happens if it reaches that point in the evaluation. One thing that you would need to know is that this is actually carefully constructed, okay, so that every clause average is greater than or equal to 90 would apply to a unique subset of averages. So we'll see an example in a second where that doesn't happen, but for example, if I had something starting out with greater than or equal to 60, assign a letter grade D first, okay? It would assign a D to an average of 92.5 or any one of the others. So you have to be careful to write it so that each condition is mutually exclusive. So this is an else if. I'll run it and it will say your 92 average translates to an A. And so we have this statement out here. And let me run it again and prove that a 72 should produce an if that assigns C to the letter grade. So looking at it again, I want to point out that it will continue its evaluation until a condition is met, and then will exit the structure. So in a word or words, it has a mechanism for early exit. It will only evaluate until a condition becomes true, and that is the nature of an if, else if, else if, else if, else structure. You can put as many else ifs that you want in the middle. Okay, you just have to construct them so that the conditions that each one evaluates do not overlap, mutually exclusive. All right, looking at a bad example here, we have a star rating method here and says, well, let's run it. Okay, I would expect a value of 14 to return a 4. But let me put 8 in. Well, let me put it in right. And temporarily screwed up the parentheses. Still a 4. And so it is less than 15. So there's something wrong here. So what I'm going to do is just kind of fix it by going greater than or equal to, greater than or equal to 10, greater than or equal to 5, and greater than or equal to 0. And let's see what an 8 returns. It should return a 2. And that's what it does. So there's an example of a badly written if-else structure where like the conditions overlap each other and lead to a poor result. There's no compiling error, it's just what they call a logic error. Now, I'm going to have to pause it for a second. Okay, you might have sensed that we had a little bit of a interruption there, and I'm going to fix some spelling here. But this concept is short circuit evaluation, and it occurs when the first part of an OR condition is true. It doesn't matter what happens in the later parts, as long as one part of an OR condition is true, it's all true. So the other way that short circuit evaluation occurs is when the first part of an AND condition is false, then it doesn't matter about the second part because they both have to be true in order for it to evaluate to true. If one part is false, then it won't even look at the second part. I mean, it won't even look at the second part. So here's an example. A is greater than B. And this is the OR symbol. So why bother looking at the second half? Because one part of it is true. It's like saying you're either greater than or equal to 18 or less than or equal to 18. It won't even bother looking at the second nonsense because the first part is true. It literally stops the evaluation. Who knew computers could be so lazy? And here's the other example. If B is greater than C, which is not the case, 7 is not greater than 12, with the AND symbol here, it won't even look at the second part. So short circuit evaluation happens when the first part of an AND condition is false or the first part of an OR condition is true. and you got to watch out for it. So, A is greater than B, true, and B is not greater than C. So, that's what occurs there. All right, let's end here with the code of DeMorgan's law. And this is going to help you in multiple choice questions. And other than that, you probably will put it in the file bin of small things that you've learned and perhaps have forgotten. I'm just saying here that not A and B is equivalent to not A or not B in every situation. So here's an example. A is true and B is false. A and B evaluate to false. And what is not false? This being the not sign. What's not false? True. And so what happens here? We output that and it says true. Not A, which is true, but what's not A is false. And what's not B, which is false, gets evaluated to true. Again, the two expressions are equivalent. Likewise, not A or not B is equivalent to not A and not B. In every single combination of A and B, this is true. So the book says, and I've heard other people say, and I say, and we all say, that in this situation, DeMorgan's law distributes the not sign and changes the connective and to an or to an and. So it distributes the not sign and to each of the parts of the expression and changes the connective or the logical operator and to or to and. Where does that come in? There's always one multiple choice question on the AP exam that is benefited from knowing DeMorgan's law, and it goes roughly like this. The following expression is equivalent to what other expression? And helping knowing DeMorgan's law helps evaluate that. So now I'm going to shift over to something else. Hi, we're going to do a little coding bat because this is one of your assignments for this week. And, like the string one problems, which most of you did pretty well, they're word problems. So they're designed to test your ability to write if, else clauses and to be able to use all the operators like less than, greater than, and or, the logical operators. Let me just go ahead and start, okay? When squirrels get together for a party, they like to have cigars. Yuck. A squirrel party is successful when the number of cigars is between 40 and 60 inclusive, unless it's the weekend, in which there's no upper bound on the number of cigars. Yeehaw. Return true if the party with the given values is successful, or false otherwise. So here we go. Notice the signature. It has a Boolean coming in and two are going out, return type, and cigars and is weekend coming in as parameters. So Let's apply the rules they gave us. If cigars greater than or equal to 40, and that's what those are, cigars is less than or equal to 60, I think. And where did I get those numbers? Up there. And let's put a little space in there. Is weak. Let's go with not is weak end. See that? The negation operator, not. Okay. Let's go return true. Yeah, that's what we want to do. And then we'll just put else. I know we're not really figuring everything out, but return false. What I like to do is type one line and then test it. So can't find cigar because it's cigars. And if I could just type better, it would work. Okay, well, 30 and false is false. So, that doesn't really say 50 and false returns true. So it's definitely working for that condition. So why don't we put an else if in here? Else if, and we'll handle the weekend situation. If cigars is greater than or equal to 40 and is weekend, okay, what are we going to do? It's the weekend. And we can return true. Okay? And it's all right. So most of these problems are going to have you create if, else structures. They're going to use the greater than, less than, and all of those equal, and not equal, operators. You'll also use the and the or. Recall that or has a lower priority than and. And one of the problems that's actually coming into play that you need to beware that or has a lower priority than and. So unless you use parentheses or something to make that get done first, it will always do the and condition first. And, those are important things. All of it pertains to reading a problem and solving it with logic. So most of the time it's your logic that's off, not necessarily your coding. But, let me know how it goes if you have extreme difficulty. Going back to logic 1, you'll see there's far more than 20 here, but you only have to do 20. So if you really, really get stumped on one problem, my suggestion is just to skip it and move on and do another problem. Okay? So hopefully you'll find all of that easy. And this has been AP Computer Science covering the Boolean logic topic.